this video, I'd like to take a look at linear functions. Okay? We've already taken a look at linear equations in this playlist, so we know how to deal with lines. The only difference now is that we're acknowledging lines as functions. Okay? A line is a function just like any other curve that passes the vertical line test is a function. So let's dive into it. Okay, here we go. Linear equations recap. A large portion of this video is just going to be review. Okay, let's revisit the definition of a linear equation. A linear equation is an equation in which each variable appears only to the first power and variables are not being multiplied together. Okay? So here's a chart that shows three different types, right? And I made this chart to show you guys that just because an equation is linear, that doesn't mean that it's necessarily the equation of a line. All right? If it's linear in one variable, the solution to this is just x equals some value. So that's represented by a point on the number line. Okay, and down here, if it's linear in three variables, it looks like this. And this equation is represented by a plane in 3D space. We're not going to be looking at planes in this playlist. Okay, so let's hone in on this type, linear equations in two variables. If it looks like this, we've got the equation of a line. So there are three forms that we need to be familiar with. All right, if it's a linear equation in two variables, these are the three most important forms. The first two forms are really cool because if the equation is in this form, we can just look at the equation, right? We can just look at it and extract meaningful info about the line. All right? So we can do that for these first two forms, but we can't do that for standard form. All right? In a previous video, I referred to standard form as useless because we can't look at it and determine anything about the line. So let's take a look at these forms and let's do a summary of each type just to cover what we've already seen, and then we'll relate it to functions. Okay? Given an equation of the form y equals mx plus b, we have the equation of a line with slope m. All right, this is the famous slope formula, where x1, y1, and x2, y2 are any 2 points on the line. We also have the y-intercept equal to 0, b. So let's see an example of a line in slope-intercept form. Okay, consider the line y equals 2/3 x plus 1. Since it's in slope-intercept form, we can just look at the equation and determine, first of all, that the y-intercept occurs at 0, 1. All right, b equals 1, so this is the point that we can plot. All right, this is the point where the line crosses the y-axis. Okay? And just by looking at this equation, we can also determine that the slope is 2/3. Okay? So let's start at this point and rise by 2 and run by 3. Okay? So we'll go up 2 units. And we'll go to the right 3 units. And that gives us another point on this line. Okay, we only need 2 points to draw a line. So this is what we have. And the next thing I'm going to do is I'm going to take this equation and replace the y with f of x. Okay, let's label this line as f of x equals 2/3 x plus 1. All right, this looks a little goofy down here. Usually I like to label my curves above the graph, but I ran out of room, so I'm labeling it down here. All right, f of x equals this. So that's slope-intercept form. Next, let's move on to point-slope form. Given an equation of the form y minus y1 equals m times x minus x1, we have the equation of a line with slope m passing through the point x1 comma y1. All right, so let's see an example of an equation in this form. Let's take the line y plus 1 equals 3/4 times x plus 3. I can just look at this equation and determine that there's a point on the line given here. All right, x1 is -3, so we have -3 in red here, and y1 is -1. So we have -1 in green here. So we can plot that point, all right? Then, once again, what I want to do is use the slope to come up with a second point on the line. All right, the slope here is 3/4, so that means that we can rise by 3. So we'll go up 3 units, and then we'll run by 4. All right, we'll go to the right by 4 units. And that gives us the point 1 comma 2. So we've got 2 points, so we can draw the line, and we can also label this line as a function, right? So what I'm going to do is take this equation and isolate y, and I get y equals this, right? Then I just replace that y with f of x, okay? I'm skipping the algebra for the sake of brevity. I just want to come up with this label here, right? This is the function that we're looking at. And once again, tragically, I have to label it down here, right? I've ran out of room again. So we have f of x equals this. All right. Next, let's take a look at standard form. Given an equation of the form ax plus by equals c, we have the equation of a line with parameters a, b, and c. Okay? So let's take this line and let's isolate y. All right? We go through some algebra to get this. Once again, I'm skipping some steps for the sake of brevity. I have y equals -2/3 x plus 2. All right? Which means that the y-intercept is 0, 2. All right, let's plot that point. And then we'll use the slope to plot another point. All right, the slope is -2/3 here, so it has a rise of -2. So we'll go down 2 units and a run of 3. So we'll go to the right by 3 units. That gives us another point, right? It gives us the point 3, 0. So we've got 2 points, so we can draw this line. And look at this. Aha! I have room to label this line above the graph this time. All right? F of x equals -2/3 x plus 2. Okay? This is the line we get. Right? This is the function formula that we get when we take an equation in standard form and isolate y. Okay? Next, let's review vertical and horizontal lines. The equation of a vertical line is given as x equals c, where c is a constant. The slope of a vertical line is undefined, and the x-coordinate of any point on the line is c. The equation of a horizontal line is given as y equals d, where d is a constant. The slope of a horizontal line is 0, and the y-coordinate of any point on the line is d. So notice the difference between vertical and horizontal lines. All right, for vertical lines, the slope is undefined, and for horizontal lines, the slope is 0. All right, 0 and undefined are 2 different things. It's important to make that distinction. So let's see some examples. All right, here I have the vertical line x equals -2, and here I have the horizontal line y equals 3. What I want to do is perform the vertical line test. All right, let's take a red line and put it right here over this black line. We can see that it intersects the black line in an infinite number of places. Okay, so it fails the vertical line test, which means that this is not a function. Okay, a vertical line is not a function. But over here, when we perform the vertical line test again, we can see that no matter where we put this red line, it's always just going to intersect the black line in one place. All right, so that means that this line, this passes the vertical line test. So this is a function. All right. So we can take this equation and replace the y with f of x, right? This is the function f of x equals 3. It's the constant function f of x equals 3. So no matter what value we plug in for x, the function always just spits out 3. The y value for any point on this line is equal to 3. Okay? So now we're ready to get into the new content. All right? Let's take what we've done, right? We've already done this on previous slides, but let's formalize it. Okay, a linear function is a function whose graph is a line. That's obvious. But linear functions can be written in slope-intercept form. Instead of y equals mx plus b, we write it as f of x equals mx plus b, just to indicate clearly that it's a function, okay? And m is the slope, which is also called the rate of change of the function, and b is the y-intercept, also called the initial value of the function. Okay, so this is pretty interesting. Rate of change is a really big topic in calculus. Okay, so we'll talk more about that in a calculus playlist. All right, and the initial value, this is also interesting. That's a big topic in differential equations. So we'll talk more about that in that playlist. But for now, let's just take this equation and let's see what we can do with it. Okay, let's try a word problem. A farmer finds that there is a linear relationship between the number of beanstalks, x, that she plants, and the yield, y, each plant produces. When she plants 30 stalks, each plant yields 30 ounces of beans. When she plants 34 stalks, each plant produces 28 ounces of beans. Write a function formula in the form f of x equals mx plus b that gives the yield when x stalks are planted. Okay? So let's look at this sentence here and this sentence here. The problem tells us that when x equals 30, y equals 30. Also, when x equals 34, y equals 28. So this is a linear relationship, and we have 2 points on the line that represents the equation. All right? Here are my 2 points. And if I have 2 points, that means that I can use the slope formula to determine the rate of change. Right? I'm finding the slope with this formula here. 28 minus 30 is negative 2, and 34 minus 30 is 4. Negative 2 over 4 reduces to negative 1/2. Okay? So the slope of this line is m equals negative 1/2. That's the first piece that we need to find. The second piece that we need to find is b. We need to figure out what b is. So let's take the equation y equals mx plus b, and let's plug in negative 1/2 for m. And then we'll take this point. This is a point x comma y on the line, so it satisfies this equation. So we can plug in 34 for x in red here, and we can plug in 28 for y in green. Okay? So now b is the only letter left over, so we can isolate it on the right-hand side. And this is what we get. 34 times negative 1/2 is negative 17. Okay? So we almost have b isolated. We just need to add 17 to both sides. And that gives us b equals 45. Okay? So we have m and we have b, which means that we can plug the values into this to get our function formula. All right? This is our final answer. F of x equals negative 1/2 x plus 45. Okay? Let's try one more problem. A phone company charges for service according to the formula C of n equals 0.1 n plus 24, where n is the number of minutes talked, and C is the monthly charge in dollars. Find and interpret the rate of change and initial value. All right? The slope, which we can also call the rate of change, is equal to 0.1, right? This is the number that's next to the independent variable n. Okay, the slope is 0.1. And what I want to do is rewrite 0.1 as 0.1 over 1. All right, I haven't done anything to change the number. Anything divided by 1 is just equal to itself. So it's equal to this. And the slope is defined as m equals change in y over change in x, right? That's what this triangle means. This is a delta. Delta y over delta x means the change in y over the change in x, which we can rewrite as m equals delta c over delta n in the context of this problem, right? C is the dependent variable, okay? And n is the independent variable. All right, so we have m equals 0.1 over 1, right? That's what we said the slope is, which means that when n increases by 1, c increases by 0.1. So for each additional minute talked, the monthly charge increases by 10 cents. That's the meaning of the slope, aka the rate of change. All right, and for lines, the rate of change is a constant, right? It's just some number. In this case, it's 0.1. So let's move on to the initial value. The y-intercept, also called the initial value, is equal to 24. So the point 0, 24 is on the line, which implies that when n equals 0, we have c equals 24. All right? At the beginning of the month, when we haven't talked on the phone at all yet, the charge is $24. Okay, so that's why it's called the initial value. It's at the beginning of the month when n equals 0. And in the context of this problem, we can call this the base monthly charge, because the phone company is charging you $24 no matter what, right? Even if you haven't talked on the phone at all, even if n is 0, you're still being charged $24 per month. And then it goes up for each minute, and it goes up by a rate of 10 cents per minute. Okay? So that's how we can interpret the rate of change and the initial value. That does it for this video. Thank you for watching, and like and subscribe.